Hello, let us do one interesting problem that came in the examination of NET June 2016. It is a simple contour integral, which I found that people have asked me as a doubt, and also that this has been asked in the NET examination itself. So this problem happens to be a good problem. Okay, so let us find the value of this integral given by 1 upon 2 pi iota integral. This is a closed integral e raised to power 4z minus 1 divided by cos hyperbolic z minus sine hyperbolic z dz. So this is what was the problem, and it was asked in NET June 2016. And let us solve this particular problem. Okay, and the direction of the contour was given to be anti-clockwise. So basically, here you do not have a problem with the sign. This is the conventional way of orienting this particular integral. So conventional way of orientation. So basically, you're going to place a positive sign only. Now let us do. So what needs to be done? The first thing that comes to mind is the formula for the integral. So you know that whenever we have to evaluate this integral fz dz over a closed curve C, it is equals to 2 pi iota into the sum of residues. Sum of the residues. Now let us first find the singularities. So the singularities. So what is the condition for singularity? This condition for singularity will be we'll have all those points a singular point where cos hyperbolic z becomes equals to sine hyperbolic z. In other words, I can say, okay, this was 2. My mistake. So there was a 2 here. Sorry. So this thing. So what does it imply? It implies whenever your cos hyperbolic z becomes equals to 2 cos hyperbolic z, that would be your condition for singularity. Now you see, if I solve this up, I will get e raised to power z plus e raised to power minus z divided by 2 is equals to e raised to power z minus e raised to power minus z divided by 2. Okay, and if I solve it, this is 2 times again. I'm forgetting. Actually, this is 2 here. Okay, so this is 1, and if I solve it, what would I get? I will get 2. So this I'll get e to power z here, and here I'll get 3 e to power minus z. Or in other terms, if I solve it up, I will get e to power 2z is equals to 3, or z is equals to 1 by 2 ln 3. Z is equal to 1 by 2 ln 3. So this is the singularity. This is the singularity that we are going to encounter. Clearly, this is a simple pole. So z equals to ln 3 divided by 2 is a simple pole for the function fz equals to e raised to power 4z minus of 1 divided by cos hyperbolic z minus 2 times sine hyperbolic z. Okay, so this is the simple pole. Now, in order to find the residue, what we need to do? We need to find the we need to use the formula this. So if you're finding the residue, so since this ln 3 by 2 is your simple pole, so I'll use z minus ln 3 by 2 into e raised to power 4z minus of 1 divided by cos hyperbolic 4z minus 2 hyperbolic sine z. I know that this particular term is it does not create a problem, but this will go towards 0 and this will go towards 0. Simultaneously, both would go towards 0. So one approach can be to use the L'Hospital rule. So I'll use the L'Hospital rule here. So I'll use what? So I'll place a limit here. So it's not going to be a harmless issue here. So I'll get e raised to power ln 3, and then I will have a minus of 1. But remaining 1 here, ln z tends to ln 3 divided by 2. If I use this, then this in here I can here use L'Hospital, because this will yield me 0 by 0 form. Why? Because after all, z equals to ln 3 by 2 came only after we equated this to 0. This is what it was. So basically what I'm going to use, I'm going to use the L'Hospital rule in order to evaluate this limit. So I'll get e raised to power 2. So this is 9 minus of 1 times this. So if I differentiate above, this is 1. And if I differentiate below, I'll get sine hyperbolic z minus 2. And the derivative of sine hyperbolic z is simply cos hyperbolic z. Okay. And all this thing we have to evaluate at z equals to ln 3 by 2. If I evaluate this thing at z equals to ln 3 by 2, what would I get? So let me evaluate here. So what is sine hyperbolic z? It is e to power z minus e to power minus z divided by 2. So this you will get, I think this will be, if I use ln, I should write root 3 minus e to power minus ln of root 3 divided by 2. So instead of 1 by 2 ln 3, I've written ln root 3. So this you will get root 3 minus of 1 upon root 3 and times 1 upon 2. This is sine hyperbolic z at ln 3 by 2. And what is cos hyperbolic z at ln 3 by 2? This will be simply e raised to power ln root 3 plus e raised to power minus ln root 3 divided by 2. Because cos hyperbolic z is e to power z plus e to power minus z divided by 2. So I hope I would write this as 8 into 1 upon, what is sine hyperbolic z? Sine hyperbolic z is simply this. So let me solve it. This will become 3 minus 1, 2 into 1 by 2. This will get cancelled. So this will be, I think, simply 1 upon root 3. If I'm not wrong, see, root 3 is 3. 3 minus 1 is 2. 2 gets cancelled. 1 upon root 3. And what about this? This will become root 3 plus 1 over root 3 times 1 over 2. This will be 3 plus 1, 4. 4 divided by 2 is 2. So this will be, I think, simply minus 2 into 2 divided by root over 3. And this 1 over root 3 would come here. Okay. And overall, this integral would then become equals to what? This particular residue will become 8 into, this is, I think, minus 1 upon, this is 4, this is 1, this is, I think, minus 3 divided by root 3. So this will be, I think, root 3. So I think answer would be minus 8 upon root 3. This is your residue. This is your residue. And the question that was asked was, there was an integral e raised to power 4z minus of 1 divided by cos hyperbolic z minus 2 sine hyperbolic z, where this contour integration was going over a closed contour. And I think I have missed something. I have missed the okay, there was no such contour given to us. I don't know where's the problem with the question. I think they should have given this thing. Just let me check the. Okay. Meanwhile, there was a, I think, 1 upon 2 pi iota. So what I should write? I should write it to be equals to 1 upon 2 pi iota into 2 pi iota into sum of residues. And only residue is minus 8 upon root 3. This would get cancelled. So answer should be minus 8 upon root over 3. So I hope I have solved this particular problem. The doubt was raised by Mohit, and I think just let me wait a little bit to just confirm the question, because I need to see what I should say. I need to see what is the contour like. Just give me a minute. Okay, unit circle, right? So it was given as unit circle. Okay. So unit circle it was given. I'm so sorry to not have mentioned the contour. So this particular contour was given over mod z equal to 1. So clearly 8 upon root 3. So 8 upon root 3 is what? 8 is around what? You can say 8 is around. So you can say what is so z is equals to ln 3 upon 2. So ln 3 is less than 1 only. ln 3 by 2 is less than 1 only. So clearly this will lie inside the contour. Lie inside the contour. Since it lies inside the contour, I have found the residue, and the residue is minus 8 upon root 3. So overall, this should be an answer. I hope everybody has got this particular solution. If there is a doubt, please let me know. Till then, take care. Bye.